Good morning and once again welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And in this video I want us to explain example 12 of Algebra 8, IGCSE 9-1 Mathematics. And state which values, if any, must be excluded from the domain of this function. Excluded from the domain. In the previous video we have understood that we cannot divide a number by 0. And we have had example 11 explaining just that. And we have also understood that we do not have square root of negative numbers. So in part A of this question, it is clear that we cannot have x being a negative number. There is no way x is going to be a negative number. And in this case, x cannot be, it cannot be less than 0. We are not going to allow such, because if x is less than 0, then it is definitely going to be a negative number, and we do not have square root of negative numbers. But when x is 0, the root of 0 is 0. For example, we may have a graph that looks like this. When x is 0, the root of 0 is 0. When x is 1, the root of 1 is 1. When x is 2, the root of 2 is known. When x is 4, the root of 4 is 2. And you're going to have a graph that looks like that. It is going to be of this nature, such that when x is now 4, this is 2. When x is 1, this is 1. When x is 9, then you're going to have y equals to the root of 9, which is a 3. So that is the kind of a graph you're going to have, but x itself is not allowed to be less than 0. If you look at part B of the question, obviously this was part A. If you look at part B, the function is 1 plus the root of x minus 2. Again, there is the aspect of the square root there. And there is no way that we can have root of negative numbers. So it goes without saying that whatever is under the root can never be less than 0. It means x minus 2 cannot be less than 0. So if it cannot not be less than 0, if we take this negative 2 across, then we are saying x cannot be less than 2. Less than 2 rather, not 0. Less than 2, because negative 2 crosses over to be positive 2. So it is very clear that x should not be less than 2. And how does this happen? Obviously, when x is 2, then you realize that 2 minus 2 is 0, and the root of 0 is 0, which we add 1 to get 1. So our graph is, let's have a graph that, let's just sketch a graph that will explain our case. When x is 2, 2 minus 2 is 0. 0, the root of 0 is 0, and 0 plus 1 is 1. So our y is 1. When x is, let's say, 4, or let's say 6, 6 minus 2 is 4. 3, this is 1, 2, 3, 4, 3, 4, 5, and 6. We can talk of the values of x. Let's just have to see what's happening down here. When x is when x cannot be 1, because when x is 1, 1 minus 2 is negative 1. There's no square root of a negative number. But when x is 2, 2 minus 2 is 0, root 0 is 0 plus 1, y is 1. When x is 3, 3 minus 2 is 1, root 1 is 1, and of course 1 plus 1 we have, let's say, a 2. Then we have y being equals to 2. When x is 6 for that matter, 6 minus 2 is 4. The root of 4 is 2. 2 plus 1 is 3. Then we have a graph that looks like this. A graph that looks like this. But you realize that that graph is not showing anything when x is less than 2. So this is the graph of y is equal to the root of x, and this is the graph of 1 plus the square root of x minus 2, and that is exactly what we were to show. In summary, in part A, x cannot be less than 0, and in part B, x cannot be less than 2. And that is now the solution to that question. Thank you. Let us meet in the next video.